Hey folks, welcome to Challenge 4. Give me a quick second here to put the prompt and the terminal or text editor side by side. And here we go. Alright, so the prompt is that you're an audio engineer and your job is to mix and master music to generate hit songs for a popular artist. Part of this involves seeing the peak volume of the mix at any second so that you can properly balance it. These volumes can range from -72 to 10 inclusive on a mix, and so given a list of numbers representing the song's volume, write a function that returns a list of the peak value at each second. And so there's some extra bullets here. If the volume falls below -72, set the peak value to -INF or negative infinity for short, then reset the peak. And then if the volume goes above 10, then set the peak value at that second to clip and then reset the peak. And so maybe this is a little bit confusing, maybe this is a little bit cryptic, but it should be made clear once you take a look at the examples. So if you scroll down and take a look at example number 1, you can say we have a 10-second song with the following volumes at each second. This can subsequently be modeled as a list with different indices corresponding to the second in the song. Now, if I put this input into the program, then the list below that in the output section should be what your program prints out, okay? And now let's explain why. At index 0, this is the first volume or the first second of the song, and so peak is the max volume that you've encountered up until this point. And so at the first second, it's the only volume we've encountered, and so that is the peak volume. Now on the second index right here, we have a volume that's louder than the first volume, and so now that's the new peak. But then starting from indices 2 through 5, you can see here that all of these volumes are lower than this peak that we've encountered already, and so the peak remains the same for all of these indices, and that's why -27 is the output value for all of these indices. However, at index 6 or second 7 of the song, you can see that we encounter a new peak value or a new max value at -12, and so that becomes the new peak for the rest of the song because no other volume louder than that shows up. Alright, so we can just go ahead and get started with that. I'm going to go ahead and create an empty list called peaks, and this is what we're going to return from this function. Right below that, I'm going to define a new variable called peak, and this is going to keep track of what the current peak or maximum value is. Now in the prompt, it clearly says that we can range from -72 to +10, and so you can set the starting value of this to -73 because anything less than -72 is invalid. And so now, as you've learned to do with lists, we need to iterate through every single value and then check if it's larger or higher than the current peak value. So we're going to do for volume in volumes. And so now we check. If we encounter a volume that is higher than our current peak, then this volume becomes the new peak, or we set peak equal to this volume. Now, after we've determined this, we need to append the value to our peaks list. And so I'm going to do peaks.append peak. And then after that, we return peaks. Notice the indentation and scoping here. I don't want to do this inside the for loop. I want to do this after the for loop has run. And that fulfills the basic functionality of this program. Now, I'm going to write my changes and then try to test this program manually. However, in order to make this easier on myself, let me show you something cool. I'm just going to create a random text file, and then I'm going to paste in these lists of values from the prompt. And now here's a cool thing you can do. I'm going to use regular expressions to get rid of all of the commas so that I can just copy each line and paste it into the input. Alright, I'm going to write my changes, I'm going to exit out, and now I'm going to cat, short for concatenate, to spit out the contents of this file, and now I can really quickly manually test my program just by copying those lines and then pasting them into my input. Pretty cool, huh? And so now I run the program, I paste in the first example or use case, and then let's compare the output here. You can see that this matches up. Okay, there you go. And so we've fulfilled the first example, if you will. We passed the basic use case. But if I rerun the program again and I go back and I copy the second example's use case and put it in, you can see here that it does not match the expected output shown in the example. And that's because we haven't implemented this particular corner case yet. If you remember what the prompt said, it said that if the volume falls below -72, we need to set the output value here to -infinity and then reset the peak. So I'm going to open up our main program again, and then now I'm going to do the check. If the volume is less than -72, I'm going to reset the peak, and then I'm going to append a different value to our output list, which is -inf. And then while I'm here, I may as well implement the last condition as well because it's pretty much the same thing. Else if or elif volume is greater than positive 10, then I'm going to once again reset the peak. And then this time I'm going to append clip to our output list. And so now we need to adjust the normal scenario. This becomes else if volume is greater than peak. Remember that if and else if conditions cascade in their checks. And so if we get down to this point, then we know that neither of these two things is true, and subsequently our volume is valid and between negative 72 and 10. And now, since we're appending different values to the output list, we're going to want to indent this inwards because we only want this to run if the volume is greater than peak. And, oh, actually, we also want this to run even if the volume is not greater than peak, right? And so how can we do this? Well, you can just slap that into the else section, right? Because if none of these things are true, then we know that the volume is valid and the volume is not greater than the peak, so it must be therefore equal to or less than the current peak, in which case we can just append the peak. And this, I believe, solves all of our requirements, so I'm going to write my changes, exit out of here, execute the program, and then paste in the input for example 2 from earlier. And now if I compare the outputs, you can see that it indeed does match. At index 2, the output is negative inf, and then I have negative 32 3 times, negative 19 followed by 2, and then 6 twice. Very good. If I execute this program again and then run the third example, you can see that the output also matches. And so we have done preliminary manual testing. All of those examples are working. And so now let's run the full suite of tests against our code. I'm going to do Python 3 test peakvolumes.py, and then you get ran5 tests OK. And that means that all the tests are passing. Remember, to fully complete the challenge, you can check the git diff if you want to see what changes you made, but ultimately you want to git add the files that you've changed, git commit with a message, and then finally git push. And that is the solution for challenge 4. Hopefully all of that made sense to you. If not, it's okay. You're just going to keep working, keep getting better at it, and eventually this will make sense to you. So really quickly, just to show you that this example problem that you were doing wasn't just some made-up BS, check this out. This is a DAW, or digital audio workstation, called Ableton. It's basically for making music, right? If you look on the right-hand side here, or actually look at all of these different channels, you'll see these little windows that say negative infinity or have like a number of some kind. That tells you what the current max amplitude or max wave is for any current track. So if I play this, you can see here that every single time a new maximum volume comes up, it changes. See? It went from negative 7.55 up to negative 6.3. It went up to negative 6.11. If I skip forward to another part of the song, you can see that the new max volume is negative 5.81, see? And so this whole concept of tracking the maximum volume, it's a real thing. You just implemented a part of a real digital audio workstation. Nice stuff. Great work so far, and now I'm going to let you loose to do another programming challenge. I know it seems like we're doing a lot of challenges now, and that's because the most important part to learning is actually applying the stuff that I tell you in the videos. And so this next challenge is also going to be more work with lists. I'll see you in a couple lessons where I go over the solution for challenge 5. Good luck.